Have you wondered how scientists predict our weather? Have you been in a situation where the weather forecast says bright and sunny and you go out and then gets drenched in rain because you didn't take your umbrella because you trusted the forecast? Have you also wondered why the same scientists fail to predict the weather correctly even with today's enhanced technology? Today, we are able to send rovers to the moon and Mars and can exactly predict where and when they would land. And yet, we cannot predict with 100% accuracy whether it would rain tomorrow within our own planet. If you have wondered about these things and do not have a clear answer yet, then this video is for you. If you have school-going kids, this is one video you can easily show them to help enhance their knowledge. Hi, I'm Anand and I welcome you to join me on this journey into the fascinating world of weather prediction, where we'll uncover the science, the challenges, and why forecasting is a bit like hitting a moving target. Let's clear something up right away. When we talk about prediction in weather forecasting, it is nothing like what you hear in astrology or numerology. In science, predictions are based on real data and math. You know, those math problems in school, like figuring out the length of one side of a triangle when you know the other two. That is a kind of foundation for weather prediction. In more advanced science, we use mathematical equations to make predictions. These equations are like tools that help us foresee things, like whether it will rain tomorrow. When all these equations come together, we call it a mathematical model. Meteorologists use these models to predict the weather. I won't go deep into the math right now, but if you're curious, you can always look it up later. Alright, let's break this down in a simple way. To figure out what is happening with our weather, we need special sensors. They are like weather detectives. Here is what they do. Anemometers check how fast and which way the wind is blowing. Barometers measure how heavy the air is, like the pressure. Thermometers tell us how hot or cold it is. Hygrometers measure how much moisture is in the air, which we call humidity. Ceilometers calculate how high the clouds are and the vertical visibility. Pyranometers, which measure solar radiation, and pyrometers, which can detect infrared radiation on the Earth's surface, are also used. We also use weather balloons, radars, and satellites from way above to help us out. So first things first, we collect all this data from weather stations and satellites. Meteorologists analyze this treasure trove of information to create a snapshot of what is happening in the atmosphere right now. Now the data that they receive is enormous. So what they do next is to break up the atmosphere into tiny grids using mathematical models. Now we have several small pieces of data similar to a jigsaw puzzle. All models need a starting point. Meteorologists initialize them with the current atmospheric conditions. The accuracy of this initial data is crucial. Remember, garbage in is garbage out. The computer, with its big brain, takes all this data and uses fancy math to figure out how it all fits together. And voila, that is how you get your weather forecast. But hang on, it is not as simple as it sounds. We'll dig into why in just a bit. Let us see the difficulties for accurate predictions. First, the different data that we receive, let's call them variables. They interact very minutely with each other. A small change in one variable could affect a whole lot of other variables. Have you ever heard of the butterfly effect? A tiny butterfly fluttering its wings in the forest of Amazon can cause a hurricane in New York. Although it's a slightly exaggerated notion, but the idea behind this chaos theory concept is that the slight agitations that the butterfly's flapping wings causes on its immediate surroundings gets multiplied several folds until it gets to a point where it can cause a hurricane somewhere else on the planet. That is how complex these variables are. So that's point one, complexity of these variables and the intricacy of their interactions. Let me give you an example. You all know that the sun's rays don't fall equally all across the globe. There are some parts which receive more sunlight than others. Even within a locality, different objects such as land, water bodies, roads, buildings, etc. get heated up very differently. When things get heated up, the air around it expands and the pressure drops. Now, air from a higher pressure area pushes towards the areas of lower pressure, thereby causing a flow of air which we call as wind. What we can say is that the atmosphere is highly, chaotic, meaning small changes can lead to significant variations in weather patterns over time. Okay, let's break it down further. There are a few more things that make predicting the weather a bit tricky. One is instrument accuracy. You see, the tools we use to measure these variables need to be super precise because everything is so interconnected. Sometimes though, our instruments aren't as sensitive as we would like them to be. We have come a long way in improving accuracy, but we're not perfect yet. Data gaps. Imagine you're doing a puzzle, but some pieces are missing. That is what happens with weather data sometimes. Especially in remote or oceanic areas, we might not have enough information. Incomplete models. The computer models that we use to predict the weather can't consider every single variable. This leads to some uncertainty in our forecasts. Local variations. You know how different places have their own variations? Like some areas are super windy while some others are calm. These local variations are tricky for the models to catch. Lastly, season changes. When seasons change, it can be tough to predict what is coming next. Think about how the weather shifts from winter to spring or spring to autumn. It can give meteorologists a real headache. So because of this complexity involved, predicting weather tends to be more difficult than predicting who will win the cricket match today. To continue with the same example, it might be easier for you to predict the outcome of one particular match, but to predict the winner of the World Cup before the tournament starts is more difficult as it involves a lot of variables and permutations and combinations. So while we are pretty good at forecasting the weather for tomorrow, the further we look into the future, the trickier it gets. Having said all this, we have made great strides in predicting the weather better than a few decades ago. Short-term forecasts, which is between 1 to 3 days, tend to be more accurate than long-term ones, which is generally 7+ days. Meteorologists are always tinkering with models, incorporating new data sources and using technological advancements to help us better understand and predict the atmosphere. Today we have specialists who focus on specific areas such as meteorologists who focus only on climate science, meteorologists specializing in severe weather analysis who monitor and predict extreme weather events like hurricanes, tornadoes, thunderstorms and cyclones. They provide early warnings and information to help communities prepare and respond to these events. Agricultural meteorologists focus on providing weather-related information and forecasts to assist farmers and the agriculture industry. They help farmers make decisions about planting, harvesting and crop management. Aviation and marine meteorologists provide weather information critical for safe air and sea travel. They help pilots and ship captains navigate through various weather conditions so that you have a less bumpy ride. In a nutshell, weather prediction is like a magical mix of science, art and a bit of detective work. Even though it's not always easy and sometimes it doesn't get it right, today's weather forecasts are better than ever, thanks to science. By understanding how it all works, we can truly appreciate the incredible science behind these daily forecasts, come rain or shine. It's a fascinating world and it keeps us prepared for whatever Mother Nature has in store. I hope you enjoyed this episode and found the information useful and worth knowing. Please share this with others so that they can become as smart as you are. Please do the usual comment and likes, and remember, each of your comment and like gives the algorithm a chance to show this video to many others, improving the chance of this channel getting more subscribers and encouraging me to get more informative content to you. Please click on the join button to become a member or hit the super thanks button to contribute for making more content. You can also use the buy me a coffee or the UPI ID in the description to support this channel. I shall be back soon with more scientific content. Until then, it's bye-bye from Pale Blue Thoughts.